Let's do an example of hypothesis testing on two populations. Here we have some data on sales in New York and sales in Pennsylvania. Let's call New York X and let's call Y Pennsylvania. The data that we have is the average sales in New York are 2 million. The sample standard deviation of those sales was 1. The number of observations was 20. In Pennsylvania, average sales are 1.5 with sample standard deviation of 2 and the number of observations equals to 20. We're asked to test the hypothesis that the population mean sales in Pennsylvania are lower than sales in New York. So the null hypothesis always has to be an equality. And so we hypothesize that sales in Pennsylvania are equal to sales in New York. And we test that against the alternative that sales in Pennsylvania are less than mean sales in New York. Let's calculate the test statistic. This is a difference in means test. So the test statistic involves, in the numerator, we've got the mean sales in Pennsylvania. Let's use the same order in which we wrote down the alternative hypothesis. Mean sales in Pennsylvania minus mean sales in New York divided by the square root of sample variance of the sales in New York divided by the number of observations from New York, sample variance of sales in Pennsylvania divided by the number of observations in Pennsylvania. Let's plug that in. We've got 1.5 minus 2 over the square root of 1 squared over 20 plus 2 squared over 20. I think we can do this in our head. We've got negative 0.5 in the denominator, and then here we have 1 plus 4 squared divided by 20. We can put it on, that's in common denominator, so that's 1 quarter. Square root of 1 quarter is 0.5, and so that gives us negative 1. Determine the rejection region. This is a one-sided alternative, so the rejection region is on the left. The alternative is one-sided and it's less than. The critical value at 5% level of significance is negative 1.64. So the rejection region is to the left of a negative 1.64. Our computed test statistic minus 1 falls into the acceptance region, and therefore we can't reject H0. We accept the null hypothesis. There is not enough evidence to conclude that the sales in Pennsylvania are statistically significantly lower than sales in New York. Can we calculate the p-value associated with this test? P-value is equal to the probability that the test statistic, which is distributed normal 0, 1, falls to the side of the rejection region. Here the rejection region is on the left, so we're asking what is the probability that the test statistic would fall to the left of the computed test statistic. And when we look that up in table, we get 0.1587. That's the p-value associated with this test. It's greater than 0.05, which means we accept the null hypothesis. We can't reject the null hypothesis. All right, what if this test was had a two-sided alternative? That is, what if we were asked that to test the hypothesis that sales in New York are just different from that of Pennsylvania? So the null hypothesis would be the same. We assume, or we hypothesize, that sales in Pennsylvania are the same as mean sales in New York, against the alternative that mean sales in Pennsylvania are different from mean sales in New York. The test statistic is the same as in the one-sided test. The computed test statistic is -1. The rejection region, however, is very different because the rejection region now is on two sides. The test statistic T is distributed normal 0, 1, but at 5% level of significance the critical values are negative 1.96 and positive 1.96, and we reject if the test statistic is either really low, less than negative 1.96, or really high, bigger than 1.96. In our case, the computed test statistic is -1. It falls into the acceptance region, and so we again conclude that we can't reject H0. We accept H0, that the sales in New York and Pennsylvania are statistically the same. Can we calculate the p-value associated with this test? P-value, well, given that this is a two-sided test, we need to take 2 times the probability that the test statistic falls to one side of the rejection region, which in our case would be 0.31. Let's see, let's multiply that. That would be 74. And that's the p-value associated with the two-sided test. And that's how we do hypothesis testing about two population means.